Hi, this is Oren from Wizsoft, introducing our node.js reverse proxy, which is also a development platform. This proxy can be put in front of any web server and enable exceptional capabilities which you cannot get on any development platform existing today. And if you'll stay to the end of this video, you'll see some true magic. We'll start simple. Once you've activated the proxy and included this JS file, which has only one command on server, you can execute from your HTML or JS file some server code. The on server accepts some node.js code. This code is inside an srv tag, and this tells our proxy that this is some server code, and the proxy replaces it with a hash for security reasons. So once this gets to the client, the survey, it looks like that. Just let me do the source. This is the page. So the code is replaced with a hash and is saved and compiled on our proxy. It will be compiled once for all instances of this code. So if you have 10,000 users viewing this page, you have the code only compiled once. Every time you change the code on the page, you don't need to do anything. The proxy recognizes the change and recompile the source code. Okay, look at this. Let's look at this simple code. We deliver this code as the first parameter, and we do console.log. Now this is console.log of node.js, not of your browser. This is server code. And in the second parameter we added a property called myprm. This is actually an arguments object, so we can, on the server, we can go to args.myprm and relate to it. So we expect to see console.log from page first param, and to client is your return function. This is what would be returned as a result of this on server function. So we expect to get in our action result all is good first param, and then we log it this time to the browser console. Let's look at this page. F5. Okay, return an object, create file, return value is all is good first param, status is okay, it was successful, and here we have from page first param. This is the log on the server. Okay, this was a very simple example. Let's do something a little bit more complex, just to show that we can go to the database. Okay, for example, here in the code we supply, we use the MySQL module. The reason we can use this module inside this code is because on the proxy, this is, by the way, all the definition of the proxy is very simple. On the base context, we said that we have a MySQL member, and which is the MySQL that I required here. So in every code, in every page, we can use the MySQL module now. Okay, we open a database, we connect. Now we have a session object in which we can keep things. This time we'll keep this open database in this MyDB member, and this will be available to any code running on any page from now, as long as you didn't close your browser, as long as your session is alive. Then we do connection.query, we select, and we filter by our account key argument, and this is the argument that's supplied to the function. We pass it to the server as an account key, and if everything goes well, we write to the client the rows that's received from this action. This time we expect to receive the full name of the account key, the full name of the account whose key we supplied as a parameter, and we call this function with an account key. Let's see what we get. Okay, we've got an array as a result. This array contains one element, full name, and this is Hebrew. This is not a bug, just a name in Hebrew. So this works. Okay, next example. Still not the magic, but we're getting there. This time we use first of all, we don't open a database, we use the DB. Just to show you, on the proxy there's a function called onNewContext. Every time a new session is created, every time a new user starts to use the proxy, the system runs this function and you can initialize its session. What I've done is I've opened the database, and on the user's session I've created a property called DB, and it holds the connection. This could be a global database, it can be a different database per session, it's your decision. Just showing you that you can initialize, you can have an initialized code for every session when it's created. So we don't need to open a database, we have our default database, we query, and this time we return all the account names for the accounts whose name is greater than our parameter, and we limit to 10 accounts. Okay, so actually when we supply an account name, we'll get the 10 accounts whose names are greater than this account name, and we call this function every time we type a character on this input element. And when we supply to the on server a callback function. This time the on server will work asynchronically because it knows it received a callback function, and what it does, it will take the result returned from the on server and just put those accounts list inside the div, inside the inner HTML of a div. That's it. It's very simple. And what we'll get is something like this. Okay, every time I type something, this changes. Now this is in Hebrew, but it works this like a suggest box. Okay, next step, and we're getting there to the magic. Next step is okay, this is where it starts to be really interesting. This time on this function we'll accept not only the key as a parameter, but we'll also accept the SQL as a parameter. Now, of course, this creates a major security problem because you don't want to give the user a function that accepts an SQL and executes it on your server. However, when we execute the SQL db.query, we don't go to args.sql. This is the, where is the parameter? Okay, we have a parameter called SQL. So you would expect that we go to args.sql. No, we go to eargs.sql.value. This means that we require that the SQL is encrypted. So how do we get an encrypted SQL? Well, to get an encrypted SQL, we put it inside an encrypt tag. This is an open and a close encrypt tag. Now we can send this function whenever time the user types, strokes a key, has a keystroke, we can supply the SQL itself to the function, and we'll see soon what power this gives us. And now I want to show you that. Go to example 5. Okay, it works, but when we look at the source, okay, this is the property, this is the data suggest SQL. It's encrypted, okay? This is how it's on the page. Data suggest SQL. However, when it gets to the client, the proxy encrypted it. So this gives us the power to create some general library that enables you to take an input text, an input control, put inside a property with the SQL, and supply its own custom suggest box. And if we go a little bit further, just take this code, put it in a JS file like this. Okay, it's a very short JS. It has like how many? 37 lines with spaces. And on the beginning we'll just create a div that we can use, we add a general event listener for all the key up events of the documents. And if the target element has a suggest SQL property, we know that it wants us to show a suggest box, then we'll take this attribute SQL and provide it as a parameter as the SQL to this on server execution. Okay, it's a little bit confusing here. This is the on server, this is the close tag, this is the second parameter which holds the parameters for the server code. We have an SQL, and this SQL should be encrypted. So again, on any keystroke on the document whatsoever, we see if there's a suggest SQL, we execute the query with the SQL and with the controls value. This is the eTarget.value, this is the key. And then we'll just take this div, put in the info, and position the div just below the target control. And what this gives us, just look at this example. We have here two input controls, each of them with a different SQL, and each of them will get its own suggest box. This means that any user can now just include your JS file and write inside any text element, encrypt SQL, and it will get a suggest box for this SQL. Let's see this in action. Okay, okay, this will go to the accounts, and this is showing the items. Okay, this item names from items, this is full name from accounts. Now imagine that you have different types of control in your HTML, and for each of them you want to have a different suggest box. You will have to write a different server API for each of them. You will not be able to do something like this. Imagine writing grids this way, taking just a regular HTML table and defining it in one of its properties to which table on the database to connect, and you have some kind of a library that creates a fully functional grid from this, which can read and even update data on this table. You can define validation rules, and actually it's very easy, fast, and fun to work this way. You can easily write a function that receives an SQL and returns the results, and inside your JavaScript or HTML file you can just put an on change of it on any control you want. For example, the user can type, I don't know, a city name, and the on change of it just go to the database, gets the city information and renders it on the client screen, and it's one line code to get this info. You don't write any code on the server, and you can still work with your PHP or .NET or whatever platform you like to work, because this is just a proxy. The proxy doesn't care where this page came from. This page can come from a PHP server or a Ruby server or a Python server, a node.js or whatever, and it just adds another layer of functionality to your server. If people like this video and it will get good comments, we'll consider uploading this project into GitHub and let you play with it. Thank you all for watching.